Dear viewers, now we are going to discussing about Earth. Uh, Before going to discussing of Earth it is one of the part in a solar system, and it is a third planet in the same, and it has a distance to maintain the distance 1 astronomical unit from Sun. Sun and only the object in the universe, and it is known as have a life. Yes, we know we are all having a life on the same planet. It is known as Earth. It is a densest planet. I mean, it has a heaviest density in the solar system, and also it is the largest of a fourth terrestrial planets. Every planet it has a gravity, and it has interacted objects with another one in a space. Similarly, Earth also having a gravity which interacts with other objects which is in space, particularly with the Sun and the Moon. Earth only a natural satellite. I mean, here it has only one satellite, natural satellite, that is called as a Moon. During one orbit around the Sun, the Earth rotates about its axis over the 365 times. Then an Earth it is about the year, almost the 1 year, that is called as a 365.26 days long. Almost all 71 percentage of Earth's surface it is covered by the water, particularly oceans and seas. Yeah, the remaining part of the area it is covered, I mean 29 percentage of land it is consisting of continents and islands, which are together they have many lakes, rivers and other sources of water which contribute to the hydrosphere. So, as my explanation, Earth it has 71 percentage of water bodies. The water bodies may be a large amount of oceans and seas and little amount of rivers. The remaining 29 percentage it contains the geomorphological features of Earth, like mountains, lakes, rivers and other water bodies which are contributes as a hydrosphere on the Earth. We know that it is a one of the planet, the Earth, and it has only one natural satellite, that is a moon. What it is that? It is a moon, and which is accompanies in its annual flight around the sun. So, the planet satellite system it is unique in the solar system, because moon it is about 3,48,000 kilometers or 2,40,000 miles. Every planet it has a origin. Similarly, Earth it is also having a own origin. So, earlier scientists they were proposed different theories on origin of a Earth. So, here also there are various scientists and family area members they were expressed and proposed theories. The first one it is nebular hypothesis. It was proposed by the Immanuel Kant and Laplace, which proposes it has a hot origin of a Earth which is formed from a single gaseous and incandescent nebula. What it is a nebula? Nebula it is called as a hot amount of gases. It is full of gases, it has a full of gases. The formation that is called as a nebula. Yeah, second theory or second hypothesis, it is a biparental hypothesis. It is called as a biparental hypothesis. It is also called as a dynamic encounter theory, which was proposed by the Buffon. And second one more, it is a planetesimal hypothesis. It was proposed by the Charles Moulton and Chamberlain. The third one, it is a tidal hypothesis. The tidal hypothesis, so it was proposed by the Janes and Jeffreys. The other hypotheses were also proposed. Example for a meteoritic hypothesis, which was O.J. Smith. It was proposed in 1944, and C.F. Whisker 1944, and G.P. Coupier's hypothesis, which is belongs to this category, and it is known as a cold origin of Earth. Previously, these whatever mentioned, like Debular hypothesis or biparental hypothesis, actually they mention it has come from the hot origin on gases, but it is quite opposite from that one. It is a cold origin of Earth, these theories are saying. Coming to the age of the Earth. In a age of a Earth, we will determine the age of a Earth. What it is the age of a Earth, how we will determine that, how we can find out the age of the Earth. We will follow the, or we will identifying the radioactive isotopes which are used different elements, radioactive elements which occur naturally in a rocks and minerals that decay with half lives of 700 millions to than more 100 billion years to stable isotopes of other elements. So, the age of Earth we can determine from the moon rocks or meteorites, which are measured by the decay of long lived radioactive isotope elements. And ancient rocks which exceeded the age 3.5 billion years found in all of the Earth's continents. Almost all Earth continents, these type of rocks which are having, and the age which is determined as 3.5 billion years. The oldest rocks on the Earth found so far are the Acasta Nices in the north western Canada near Great Slave Lake, that is as a 4.03 giga annum. So, these are all the examples. So, based on these examples, we can estimate, definitely we can estimate with using of different radiogenic or radioactive isotope elements. With using of those, we will determine the age of the Earth. The oldest dated of moon rocks, however, those have age between approximately that is as a 4.4 to 4.5 billion years. So, this is exactly these ages were matched with that one. So, we will consider these ages, and simultaneously they have carried out different rock samples, and with studying of isotope elements for the dating of the same, and finally, they have decided some amount of age of Earth. That may be the age are approximately 4.54 billion years, which is found in the solar system, and Earth it is consistent with current calculations of 11 to 13 billions for the age of a Milky Way galaxy, and finally, they have concluded that the age of Earth was 4.5 billion years. Now, this is the exact figure. Now, we can say as per this, what is, suppose if someone ask you what it is the age of Earth. Yeah, suddenly definitely you can say that answer blindly, definitely have to say that is the age of Earth it is a 4.5 billion years. It is a confirm 4.5 billion is they decided. Then coming to the shape and size of the earth. Shape and size of earth, the shape of earth, it is spherical. The earth's shape, it is spherical. Shape, it is a shape of a shadow, it is showing. So, that the earth it is seen against the face of a moon during a full moon lunar eclipse. To full moon or full lunar eclipse, it is also known, it is also showing as a spherical. But careful observations we need for this. Yeah, somebody is saying it is a spherical shape and elliptical shape, or someone will say it is a pyramidal shape, but actually the final we need some final decision. So, that but carefully we have to observe by the several eminent geographers which were concluded that the shape of earth, it is not perfect sphere, but sometimes we may see it is as an oblate spheroid. So, now we come into this one, it has a oblate spheroid, this is the perfect shape. Finally, they have a decided that it is as a oblate spheroid. And the earth equatorial, yes, we need the radius also, it is important to us from the polar regions. So, that what it is the length we have to measure. So, then the earth's equatorial, it is 12,756 kilometers, whereas the length of the polar diameter, it is known about 12,714 kilometers. Now, composition of a earth or constitution of a earth. In a crust, actually we internal structure, if you can see here, in a internal structure, if you can see that we know that crust, mantle and core. There is three types of major formations we will see in a internal or vertical section of a earth. So, here there are some discontinuous we have. What are those discontinuous? Here we see the top layers almost 5 kilometers to the up to 100 kilometers level. It is known as a lithospheric formation. It is known as a lithosphere, because of it almost it is the formation of earth or the formation of rocks will be there here. So, the study it is known as a lithology. The formation of rocks, it is called as a lithology. So, it is completely occupying by the rock formations or different rocks. So, this area or the that sphere, it is called as a lithosphere here. Lithosphere we are calling that is, and then later 200 kilometers and dividing the 200 from 100 kilometers to up to 6 or 670 kilometers. We know that is as upper mantle state, that is called as a upper mantle. Here there is a Mohorovic discontinuity. Mohorovic scientist who found that professor is a great seismologist in a Yugoslavia. He found that on his name that discontinuity, it is called as a Mohorovic discontinuity. So, here the crust we will speak about first, or we will discuss about the crust, the top layer of earth. So, here crust again it is three types here. One, it is under the oceans 5 to 6 kilometers it has under the oceans, and again under the continents here 30 to 35 kilometers depth it is occupying. Third one, it is under the mountains also we can able to see, or we can able to identify the crust, that is a 60 to 70 kilometers of a depth formation. Then what it is maybe composition. Every rock or example I am saying, every rock or every soil formations or every part you can take it, it is made up of different chemical elements. So, here also the crust material or a crust, it is also made up of by the different chemical compositions or mineralogical compositions. So, there are familiar scientists, they were found, those name are called Clark, Washington, Goldsmith and Plodovarat. They have collected the different rock samples and they have analyzed, and finally which rock or I mean the crust, it is containing the which what type of material it will be there, or minerals it will be there, or it will be present in that one. Yeah, the first one, it is silica. Silica, almost it is a very dominant character or a dominant component. The value lies above the 50 percentage by volume in the oceanic crust and above the 62 percentage in a continental crust. Yeah, there is a differentiation in the silica presence in the oceanic crust. It is a 50 percentage by the volume in the oceanic crust and 62 percentage in the continental crust. The second one, it is alumina, Al2O3, it is known as Al2O3. The Al2O3, it is the next dominant component, the highest component, it is present in that one. The value almost it is vary between the 13 to 16 percentage. And third one, it is iron oxides. In iron, these iron oxides, actually it is associated with the different rock formations, maybe 8 to 10 percentage will be present. And the next one, it is lime, CaO, lime means CaO, and sodium oxide, NaO 4%, and magnesium oxide 4%, potassium oxide 2.5 percentage will be there, and the titanium oxide 2 percentage. And other components will be also there, the remaining components, remaining percentages. Then coming to the second layer, it is mantle. Yeah, I told you just now, that is S. Mohorovich, who was a very familiar scientist, and he was from Yugoslavia, and first he was discovered the fact in 1904. The depth below the surface of the earth, that means below the surface of earth, at which a striking change in the properties of a material, and it is observed, has been named Mohorovich discontinuity, because of he found that. So, that is reason they gave Mohorovich discontinuity. Mantle below the mohos and forms nearly homogeneous zone till depth. It is occupying the approximately 2900 kilometers. There we can again it is divided into the two parts. One, it is outer mantle, and second one, it is inner mantle. Depend on that, approximately 670 kilometers. So, from the 50 to 670 kilometers, the area it is known as upper mantle. From that up to 2900 kilometers, it is known as a inner mantle. Mantle, what it is a composition here? In a mantle, maximum it is association of ultra basic rocks here, ultra basic compositions, and it is having the very rich and iron magnesium. But very little component of silica will be there, and there is no, maybe sometimes maybe very less component present, the alumina or less very component, it is very less percentage will be there. And this zone, it is characterized with density. When we are going to the deeper level, almost just you can imagine what it is. 670 kilometers means it is not a it is a very great depth, it is not a joke, and you can just imagine what it is that hot material will be there in that one, and maximum the iron and magnesium composition will be more and more in that case. And third one, it is core. The core, it is the third and the inner most structural shell it is of our earth, and it is completely it is provided by the seismic evidences only, which is the starts after the completion of that inner mantle. from 2900 kilometers below of the surface, and which is extended up to the center of the earth, that is maybe 6370 kilometers of a depth. It has a very great depth. The liquid material will be there, completely the liquid material will be there, where it will be available. Yeah, definitely we can say the depth approximately from 2900 kilometers to about 4800 kilometers up to there. The again it is also divided outer core and inner core, these two. As per that we can say 2900 kilometers to up to 4800 kilometer, till that we are calling that it as a outer core, and from 4800 kilometers to up to 6370 kilometers, it is a unknown nature. We have unknown nature, we know, we can't to say directly yes whether the material it is a lipid or what it is that, and which components will be there in that one, we can't to say directly that is. So it is a inner core, from where it is starting from. It is started from 4800 kilometers to up to 6370 kilometers, till that area we are calling that is as a inner core. And according to that widely favored view, the core may be made up of iron and nickel. Yes, definitely in a outer mantle we have seen that is iron and magnesium. Then when we go into the deeper level of this one, we can see here the material or the components here, iron and nickel. Here there is a differentiation, iron and nickel. It is known as a NiFe. It is known as a NiFe. Nickel NiFe, NiFe. Ni means nickel and Fe means ferrous or iron, NiFe. Yeah, this is the internal structure of a earth. Yeah. Next, coming to the continental masses and ocean basins. Yeah, almost 197 million square miles, which is make up that surface of earth, and nearly 70 percentage covered by the interconnecting bodies of sea water or oceanic water, or Pacific Ocean alone, the covering the fully 1/3 of the globe. The average the depth maybe it is the 14,000 feet, it has 14,000 feet, it has the depth. So, the area of a land and a sea floor between successive levels also has been, which is estimated the suit interesting results are obtained. Accordingly, it is known that there are two dominant levels. Yeah, one it is continental platform, and second one it is deep seated or deep sea platform with a gentle slope. It has the gentle slope, it is called as a continental slope. We are calling that is as a continental slope. Then this continental slope, it is connecting with the both of them, what I told you. One it is a continental platform, and second one it is a deep sea platform. It has a gentle slope called, it has a gentle slope, so that the gentle slope it is known as a continental slope. It is react or it is connecting with the continental platform and as well as the deep sea platform. Some geological process will be occurred in a earth changes. The earth changes of all kinds have been going to earth. Its crust on its surface. The surface it has different materials, and it is how I mean it has structures, and then the distribution of a land and sea, mountains, plains, even climate and weather. These are all compositions will be there on a surface of earth. The processes responsible for these changes are called geological processes. That means what I told you till now, the earth crust is contains surface in its material, in its distribution, land, sea, mountain plains and weathering particles or climatology, these are all will be done by the process, These are all the geological process we will see in a geological processes. There are some external processes also there. What are those external? The external origins, which includes the weathering, erosion and deposition. Weathering, erosion, deposition. These are all these three are external processes. In the external processes which are operate on a surface of the earth tending reduce to many particles, and hence then finally it is formed finally it is going to form as a one new formation. So, that is depend on their various processes of gradation and denudation of particles. As per that, those the new formations will be started. And second one, it is internal processes. In a internal processes, the internal origin means here what we will conclude, what we will consider igneous activity of earth formations. Igneous activity depend on the igneous activity, the internal process, the internal arrangements will be done within a earth's crust. As per a plate tectonic theory, plate tectonic boundary or plate tectonic theory, the earth's outer space, it has a rigid lithosphere, and it is going or it was broken in different pieces. Then these pieces are called plates here. These pieces are called plates. So, the very slow movement of these plates within the asthenosphere, and which are caused to move relation to the one to another. While it is moving, it is a divergent movement, that means the plates were separated from one to another and they move far away from one to another. Then again the second process convergent, it will come towards to each other, the boundary it is going to be met. So, that due to this region, the earth it is going to be formed. It is we are calling that is depend on the plate tectonic movements. So, overall the study of this earth, first we have to consider that is as a earth, it is a oblate spherical shape. Then the equatorial length, that is also we have to consider, that is maybe 12,756 kilometers, and polar diameter, that is also we will see, and we will see and we will consider that is as a 12,714 kilometers. Then the composition of earth also we will consider. Here the before going to that composition of earth, the crust also we will see. There are I told you that is three types of crusts we have to identify. One, it is under the ocean crust, the depth may be or the thickness of that, it is 5 to 6 kilometers, and second one, it is under the continental crust. The continental crust, it is 30 to 35 kilometers we will consider, and again the mountains also it has a bone crust, and it is also considered as the third part of a crust under the mountains, it is a 60 to 70 kilometers. Then the after this one we will compositions, different mineralogical compositions also we will check out, that maybe it has a silica percentage or aluminum percentage or iron percentage, whatever it is, that we will calculate. Next one, next if you go into the mantle, again the mantle it is a two types. So, we have a mantle, one it is a outer mantle, second one it is a inner mantle. In a outer mantle we will consider that is for approximately 50 to 670 kilometers of outer mantle we have. Now, then what it is a composition, that is also we will see the composition of that one, maximum it contain the iron and magnesium composition will be there. Then inner mantle, if you come into that inner mantle, that means 672 approximately 2900 kilometers of a depth it has. Then again that is also having the almost all same composition there. Then the final one, and the final structure in this one, it is a core. The core approximately it is starts from 2,900 kilometers. I told you that where till up to 6,307 kilometers will be there. So here also we can divide, that is two types of cores we see. So external internal processes will be there in a process. In a external processes, whatever above the surface it has features and formations, all those will be considered, including with the climate and water, those are all will be considered as a geological process in external. Okay, thank you.